Number one, who remembers our little shortcut formula to find the axis of symmetry of a parabola? This is a parabola, x squared. Who remembers our little formula? X equals tomorrow, x equals negative b over 2a, and in our particular problem, a is 2 and b is negative 8. So here we go. Negative b will be 8, and 2a's will be 4. So 8 over 4 is 2. So my axis of symmetry is x equals 2. That automatically means what about my vertex? That is 2. Yeah, whatever that is, that's that, every time. Then how do I find the y part of my vertex? Plug in 2 right back there. So I'm going to have 2 squared minus 8 times 2 plus 3. Now you can absolutely use your calculator to do this, or a calculator to do this, but be careful when you put it in. You're squaring first, right? So that's going to be 8 minus 16 plus 3. I believe that's negative 5. And which way do I open? It's always up or down. This one's up. Why is this one up? Because that 2 right there has more negative. That's right, there's a positive. That number right there tells you which way you open. Positive is up, negative is down. Right? Now, for the next one, we have to remember we have 2 kinds of variation. We have direct and we have inverse, or indirect. Anybody remember our basic formulas? For inverse, it's y equals k over x. For direct, it's y equals kx. And you don't know which one's going to be on your quiz. So you need to know both of them. This particular problem is inverse. So it says volume, and when I did this before, I was using boxes. You don't have to use the boxes, but when it says inverse, that's your format. And your variables are volume and pressure. So our equation we're going to use is V equals K over P. That is going to be our setup. All right, is this coming back to you? It's been a couple of weeks. When pressure is 10, volume is 60. So what did I just do? I plugged in the 2 numbers they gave me, right? For P and V. Now that's solvable. What does this tell me K equals? What does K equal? Question, but I know it. Find the volume when the pressure is 16. So here's my formula. Find the volume when the pressure is 16, but now I know K is 600. So I can just figure out what that is, or I can reduce the fraction. So if you get it decimally, you got 37.5. If you get it fractionally, you got 75 over 2. It doesn't matter which way. this was sentence number 1. Volume varies inversely as pressure. And then this was sentence number 2, putting in the 60 and the 10. And then this was sentence number 3. So each sentence of the problem gave me something to write down. All right, now we're sketching this guy. No, you don't have to do any factoring, you don't have to do any division, you don't have to do anything except plot your x-intercepts. Where are you going to put them? -1, we're going to label it.
Plus
+3 and -3. And then you're going to count up how many x's you actually have. Now, I know your eyeballs see 3, but there's more than that. Because this is 2 right here. This is 2 more, and that's 1. So we have 5 x's. 5 is odd. Where do odds start? Down here. And then every time you hit a dot, you ask yourself, what am I doing? Am I going through it? Am I bouncing off of it? That dot came from this factor. So what am I doing? I'm going through and connecting. That dot came from this factor. What am I doing? Bouncing and connecting. That dot came from this factor. What am I doing? Bouncing and inertia. Okay, so tomorrow's quiz is going to have 3 problems on it. One of them is going to be find the vertex axis symmetry direction of opening. One's going to be a variation problem, and one's going to be sketch. But the sketch is already going to be factored for you. So this is not one where you have to do the synthetic division and all that. What? Oh my gosh! Thank you, Gabby. Oh my gosh. Does the negative change anything, she says. Does the negative change anything? Yes. What does it change?
It flips.
It turns it upside down. Thank you, Gabby. So a normal 5th degree, we counted 5 x's, would start down here. But because of the negative, which, oh yes, does change something, we're going to start up here. Now, we're still going to go through and bounce, same places we were going through and bouncing before, but now it's in the other direction. Thank you, Gabby. Next time, I'm going to try to remember to circle that, so I'm going to forget about it. Okay? All right, let's put that aside. Please don't lose it, because we're going to do that another time. And then, let's get our notes out. And we're ready for page 19. Is 3 a factor of 19? No. How do you know that? Because when you do the division, what do you have? A remainder. So how could I tell if that's a factor of that? Divide. And if I'm going to divide synthetically, what's going to go in the box? If I'm dividing by that, 1. Very good. Remember, every time you put a number into a parentheses or take a number out, it's the opposite. So this means 1. I'm going to divide. Is it a factor? What was the remainder? And when the remainder is 0, you have a factor. So the answer is yes. Why? Because I divided and got a remainder of 0. Now I'm going to show you something else. And then in a minute we'll talk about why it's a valuable thing to know. But if I were to go back to the original problem, and I thought of the original problem as a function, instead of doing the division, if I would have plugged in that number, the same number that I divided by, if I would plug it in, I want you to see what happens. What is 1 cubed? 1. What is 1 squared? What happens when you add all that up? You get 0. When you plug the number into the problem as though it were a function, the number that comes out is the remainder. Now I'm going to show you in a second why that is kind of a cool thing, can be very useful. But I don't want it to mess you up. If the question says, is it a factor? Can you always divide? Yes, you can divide and see if the remainder is 0. All right, you try the next one. Is x plus 2 a factor? If we're doing the division, what are we putting in the box? Negative 2. Okay, beep, 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 alert, alert, alert. When you write down these numbers, starting with 1, you need a 0. Why do I need a 0? There's no x cubed. With synthetic division, that is essential. You've got to pay attention to that. Plug in a 0 for anything that is missing. Is it a factor? No. Why not? Because you have a remainder. If it's a factor, that right there will turn out to be 0. And it didn't. Using my other little trick called the factor remainder theorem I was talking about a minute ago, I want to plug in negative 2. You don't have to do this with me, but I just want to show you what's going to happen question. So we know what we need to do, right? We need to divide. But what's the issue with division this time? A lot of zeros. A lot of zeros. This division is going to be very big. And if this were something like this, it would be even worse, right? So it's helpful to remember, if you can, that if you treat this like a function and plug in the number that you would have put in the box, then you don't need to worry about the zeros. You would just plug this in. And get your answer, which is no, because the remainder is not 0. So you have two ways of answering the question. One question is just straight up dividing, and the other way to answer the question is to plug the number into the problem, plug in -2, in this case -2, and whatever comes out is the remainder. If that comes out to be 0, you're a factor. If it doesn't, you're not. All right, one more type of problem to do, number 7. Someone has already started the problem for you. Somebody has taken this thing and figured out that one of the roots is x equals 1. Somebody's already done that for you. So in other words, if you were graphing it, which it doesn't say to graph, you would already know one of your dots. How many other dots are there going to have to be? 2? 2 more? And your job is to find those. Right? Any idea on how you might do that? Find the other 2 missing ones? No. Don't plug in 1, because if I plug in 1, no, you're right here. If I plug in 1, I'm going to get 0. And that isn't helpful. What I want to do is divide out 1, because when I do the division, I'm dividing by that number. When I do that division, I know my remainder is going to be 0. What I'm interested in is the quotient. So what is that quotient going to be? Well, let's see. See that 0 right there? That's awesome. But what's left? That's the interesting part. What is this? 3x squared plus 7x plus 2. And what am I going to do with that? Come on now, we've done this before. What do I do with that? Factor it. Now, and if it doesn't factor, I'll have to use my quadratic formula. But one way or the other, I'm going to solve this. I think this one factors. Yeah, that works. So what are the other 2 roots? In other words, if you were going to put 2 more dots on this picture, we have the one they gave us. What are we going to get out of these? This one's going to be x equals -2. And this one's going to be x equals -1/3. So the question was, find the other 2 zeros, find the other 2 roots. There they are. And how did we find them? We took the one they gave us and divided it out and solved what was left. So, everybody is tired and out of it, as you are. Everybody should be able to do the next problem. You have been told that 8 is a root. So what goes in the box? 8. Because I'm not putting it in a parentheses or taking it out of a parentheses. 8 goes in the box. 1, -4, -44, and 96. I'm going to divide that out. Am I surprised I got a 0? No. I knew that was going to happen. How did I know that? They told me this was a 0. Zeros give me 0. That's why they're called zeros. What am I interested in? Which is what? What is this? X squared plus 4x minus 12. That's the part I care about. And you can either factor it or use the quadratic formula, whatever works for you. I think this factors. How does it factor?
Plus 6 minus 2.
Thank you. Which means the other two zeros, or the other two roots, are x equals -6 and x equals 2. They gave you 8. They said find the other two. There they are. All right, well, I'm handing out some papers. I want somebody, all of you, to work on that last one. And I'd like somebody to come up and do it on the board for us. Let's get that blood flowing. Do I need to call on somebody? Do I have a volunteer? Don't look down, Kyle. I know you want to volunteer. Come on. Bring him with you, or bring someone with you who you think might be valuable. All right, what do the rest of you think about what the great triumvirate did up here. Step one, they divided out 3. Was that a good move? Yeah, there's their 0. They did that. So then they took what was left. Factored it. They got -2 and -5 as the other groups. Good? All right, one quick comment here before I hand out the practice test. I just returned some homework papers, and we'll probably look particularly at homework 2.3. If you have turned that in, get that out, homework 2.3. If you haven't turned it in, well, you probably should be doing that. I want to look at problem 1B. Very many of you missed this problem. And we need to make sure, well, first of all, this is our quiz tomorrow, where I give you something that's already factored. You have to get it right. I'm going to go ahead and circle this. Does that negative make a difference? Oh, yes, it does. I'm going to circle it this time, so don't lose track of that. Now, notice that in this problem, this is homework 2.3, number 1B. Notice that there are no squares. So that simply means that I won't be bouncing, right? However, you must also notice that there are 3 X's present. Written in the problem are 3 X's. That means there need to be 3 dots. And all of you who did the problem put 1 at -3 and 1 at 4. That is absolutely correct. But there is another X, you guys, right here. He gets a dot. Every X that you see physically in the problem is going to get a dot. Where is that dot going to be? At the origin. That dot is at the origin. So if your problem has 3 X's written down, you see this 3 times, 3 dots. 4 of them, 4 dots. Now, if I put a power on here, there's still just 3 dots because there's still just 3 literally X's. That would be 4 in terms of the direction of the curve, but only 3 dots still. Okay, negative comes into this. So this is the way that one should have looked when you graphed it. All right, is that okay with everybody? All right, that one was missed a lot. Why don't we go ahead, since we have this homework out, another one that was missed a lot, quiz number 2. This is not on your quiz tomorrow, but it will be on your test. So let's just go ahead and review this problem, and then we'll do our practice. Your job is to write the equation of this function. So what do you do first?
Take the points and put them in.
Write down your parentheses. And since I see 1, 2, 3 dots, I'm gonna have 1, 2, 3 X's in the problem. And what are those parentheses going to be? X plus 3 plus 1 minus 2. Everybody okay with that? Now pay attention. Is this parentheses that have squared? No. How about this one? Yeah. How about that one? Yep. So far, so good? Now, some of you stopped there. And you shouldn't have. There's a number out here in front of you. Call it something, right? It doesn't matter what, call it something. And we have to figure out what that number is. How do we figure out what that number is? We take this other point, which doesn't have anything to do with the parentheses, with another random point. Its x and y are going to go into the equation. This is y, so this is negative 3. Negative 2 plus 3. Does everybody see what I just did? Now I do the math. Negative 2 plus 3. Negative 2 plus 1. It's negative 1, but it is squared, so it's 1. Negative 2 minus 2. Negative 4 squared is 16. These are all multiplied right here. So negative 3 equals n times 16. So n is negative 3/16. All right. All right, let me hang out your practice test and we'll get started on that. I would count on a test as early as next Monday. Maybe before next Monday, like that. Could be next Monday. This will be good. Additional quiz practice hours too. Remember we have a quiz. And 2.5 homework is due on Wednesday. Alright, so 2.5 homework due on Wednesday. And this tomorrow. Alright, here we go, number 1, which of the following are polynomials? If not, why not? Well, we had a quiz over this. You remember your rules. How about A? Yes. Nothing wrong with that guy. How about B? No, because you can't have an X in the denominator. Right, folks? How about C? No,
X in the radical.
can't have an X under the radical, right? Can't have an X under the radical. Can't have one in the denominator, and you can't have one in the denominator. How about D?
Yep.
Good, all good. This word's got fraction in it. I don't care as long as the fraction isn't an exponent, right? Fractions are fine, but not when they're exponents. And then what about E?
No.
Nope, no negative exponents allowed. It's just because we haven't studied. All right, number 2. Write the equation of the linear function where f of 2 is 3 and f of 4 is 9. You guys have a quiz over this also. What do we do? Well, yeah, so first of all, we recognize these are points, right? X, Y. And so Gabby says we find the slope. 9 minus 3 over 4 minus 2. 3. Then what? Pick a point. Doesn't matter. I'll use this one this time. Y minus 9 equals 3x minus 4. Distribute. Get y by itself. Then I'll write it as a function. So f of x equals, I got 3x minus 3. Can we match that?
Yeah.
Does it have to be written as f of x?
Yeah, it says write a linear function. That's not gonna be a huge deal, but yeah. Now, that one we've done a lot of and it's relatively easy, I think. The next one could be the hardest question on your test. This time, we're writing a quadratic function. Which means it isn't going to be like slope and stuff. A quadratic means it's going to be an x squared. And in order to do this problem, you have to remember what a parabola looks like in vertex form. Here's what I mean. You know that is your squaring function. But you also know we can change it by putting a multiplier out in front, adding or subtracting to x, and adding or subtracting out here. Would you agree that's still a parabola? Right? Where's the vertex? The normal vertex is at the origin. Where is the vertex of this guy? 3, comma, write 3 up 4. 3, comma 4. All right, that's what you got to remember. That this is what a parabola looks like. Because when I tell you this is the vertex, you need to be able to translate that. I don't know what that number is, but I know what has to be in the parentheses. If the vertex is right 1, this has to be x
Plus,
minus 1, right? If I'm going right 1, and then down 2, that is the beginning of my parabola. Right 1, down 2. Right 1, down 2. And then what's missing is that number out front. But I'm gonna find that the same way I found one earlier. How do I find that number out front? Plug in this other random x and y. So 2 equals n times 2 minus 1 squared minus 2. Just plug it in, just like we did before. What is 3 minus 1? 2 squared is 4. Now be careful. That 4 is hooked to an n, so that's 4n. 4n minus 2. Don't subtract the 4 and the 2, because that 4 is still hooked to the n. So then we'll responsible for number 3. If you recall, I didn't, have that with you. Number 4, however, is on your quiz tomorrow. Find the vertex, axis of symmetry, and direction of opening. And actually, there's 2 of those. All right, give me numbers. X equals negative b over 2a is how I find my axis of symmetry. So our axis of symmetry, A is 1, B is 4. So negative b over 2a's, I got x equals negative 2. What does that tell me about my vertex?
X is negative.
X is negative 2. These match, always. And then you still have to find the y. How will we find the y? Plug negative 2 back into my equation carefully. Especially if I'm going to do this on my calculator, I gotta make sure I'm paying attention. So negative 2 squared is 4. Minus 8 minus 3, what does all that add up to? Negative 7. And which way does this guy open? Oh, and he opens up because A is a positive 1. All right, got another one just like it. Go ahead and try this one. Vertex, axis of symmetry, direction of opening. I'm just gonna say up right away. Can I do that?
Yeah.
Yeah. Watch this one. What's a little tricky about this one? What's A? 3. A is 3. But what's B? 0. You don't have a B, which is fine. That's fine. A is 3, B is 0. So your axis of symmetry is going to be 0 over 3, which is 0. Which means your vertex is 0, comma, what do you get when you plug in 0? Negative 8. Boys and girls, don't just stare blankly. 0 squared is 0, times 3 is 0, minus 8, negative. That's on the quiz tomorrow. So is problem 5. Temperature varies directly as volume. T equals, okay, turn times V? Why is it K times V?
Correct.
This is direct. On the practice quiz, it was inverse, so it's K over V. If the temperature is 10, the volume is 28. So K equals 10 over 28. Everybody in agreement there? Which, as I mean, I'm gonna go ahead and divide this 5 over 14. What do you say? I'm not worried about that number. I'm not worried about that at all. Find the temperature when the volume is 50. Find the temperature when the volume is 50, but I already know K is 5/14. So all I need to do is multiply these two together. And I can do it with or without my calculator. If I do it by hand, I get 125 over 7. If I do it on my calculator, I'll do decimal. 17.86. Is that okay? I am going to run out of time. I'm going to skip 6 for a moment, go to 7, because 7 is also on your quiz too. So we will have practiced all 3 of the quiz type problems. So this is number 7. So as I wrote it, I noticed that there's no negative. Don't have to worry about that. It's not going to be upside down. Okay, how do I start? What do I do first? Let's put the x-intercepts on. So I'm going to have an x-intercept at 1, at -3, and at 2. Now there are 3 x's. 1, 2, 3. So there are 3 dots. But I really have more x's than that. Because this one counts as 2 and 2 and 1, so there's 5 x's. Which means, it's odd, 5's odd, which means I can start down here. And when I hit that, I gotta pay attention. That one came from here. And it is square. So it's going to balance and connect. That one came from here, and it is also squared. That one came from there, which is not squared, so it's just going to go on. Okay, all right, I'm gonna stop here. Tomorrow we have a quiz, homework due on Wednesday. You have some other homework